Let's talk about machine learning components. Machine learning is a subset of artificial intelligence. It focuses on training models to learn from data. There are three key components in any machine learning system: data, algorithms, and models. Data forms the foundation. It can be raw input in the form of text, images, or numerical values. The algorithm acts as the instructor. It defines the rules and procedures that guide how the learning process unfolds. The model is the final result, the trained system that has absorbed patterns from the data using those rules. How machine learning works. The process of machine learning involves training a model by applying algorithms to datasets. During training, the algorithm examines the data and identifies underlying patterns. The model then adjusts its internal parameters, such as weights in a neural network, to reflect what it's learned. Once training is complete, the model is tested on new, unseen data to evaluate its performance and accuracy. Consider the task of classifying movies as either action or drama. Suppose we have two measurable features: intensity, which might include factors like explosions, chase scenes, and loud sound effects, and dialogue density, which refers to the amount of spoken content and emotional depth in the film. Typically, movies with high intensity and low dialogue density are action films, while those with low intensity and high dialogue density are dramas. Using this knowledge, we can train a machine learning classifier with a labeled dataset, a collection of movies where the genre is already known. If intensity and dialogue density are measurable, the model can learn the relationship between those metrics and the movie's genre. Then, when presented with a new film, it can predict the genre based on the learned patterns. The further a movie's characteristics are from the dividing line between genres, for example, a film with extremely high intensity and almost no dialogue, the more confident the model will be in labeling it as an action film. This confidence comes from the distance to the decision boundary and plays an important role in how reliable the prediction is. The main idea to take away is this: the more complex the relationship between the input and the output, the more powerful the machine learning model must be to accurately capture that relationship. Complexity increases when there are many input features or many output categories. In tasks that involve subtle patterns, such as recognizing images or interpreting human sentiment, more advanced models are needed. Simple models like linear classifiers may not be sufficient. This is where neural networks become important. When simpler methods fall short, neural networks, especially large ones, are used to uncover deep and intricate patterns in the data. These networks are composed of many interconnected units, or neurons, which allow them to model highly complex relationships. For example, in a text generation task, a large language model can be trained on vast datasets made up of sentences. Over time, it learns to predict the most likely word to follow a given phrase. This enables it to generate coherent and context-aware text, simulating human-like language and reasoning.